In the last lecture, we looked at the unit circle, so let's just review the unit circle very quickly. We said that the unit circle is a circle with a center at the origin and a radius of 1. So how do we draw that circle on the coordinate plane? We have our 4 points at 1, 0, 0, 1, negative 1, 0, and 0, negative 1. We connected those points. And we said, okay, well, to find the equation of the circle, we can create a right triangle where we call any point on the circle x comma y. And the horizontal distance of the right triangle is x. The vertical distance is y. And we know, because it's the unit circle, that the radius is 1. So the equation of the unit circle can be identified by the Pythagorean theorem. X squared plus y squared is equal to 1. Remember, an equation is just a relationship between x and y for every point on the circle. So since that's true for every point on the circle, that would be the equation of the circle. Then we said, okay, we can look at angles within the circle. So every angle is measured starting with the positive x-axis, which we'll go through in a minute, and how far we've walked around the circle. So we said at 1, 0, that's our starting point. So as we walk around the circle, you can see that we could take the positive x-axis and we could take a line that connects the point where we are to the origin, and that creates an angle. So you can see angle theta here. So here we've walked 0 degrees. When we get a quarter of the way through the circle, we've walked 90 degrees. Halfway around the circle, 180 degrees. 3/4 of the way around the circle, 270 degrees. And finally, a circle has 360 degrees. Then we said, okay, well, we can also measure these angles in radians. So in radians, this is 0 radians. Halfway around the circle is pi over 2 radians. A quarter of the way through the circle. Halfway through the circle, we're at pi. 3/4 of the way through the circle, we're at 3 pi over 2. Remember, this is 1.5 pi. So pi is halfway plus an extra quarter. Then finally, we have all the way around the circle, which is 2 pi. We also said that the sine of theta, the sine of our angle, is y over 1. So the y value at every angle is the sine of that angle. And the cosine of theta is x over 1. So whatever our y coordinate is, that is equal to the sine of the angle. And whatever our x coordinate is, that's equal to the cosine of the angle. So this is saying that the sine of 90 degrees, or of pi over 2, is 1. And it's saying that the cosine of 90 degrees, or the cosine of pi over 2, is 0. Here, the sine of 180 degrees is 0, and the cosine of 180 degrees is negative 1. We can say the same thing about pi. Sine of pi is 0, cosine of pi is negative 1. Sine of 270 degrees, or 3 pi over 2, is negative 1. The cosine of 270 degrees, or 3 pi over 2, is 0. And finally here, the sine of 0 degrees, or 360 degrees, or in radians, the sine of 0 or the sine of 2 pi is 0. The cosine of 0 degrees, 360 degrees, or cosine of 0 or 2 pi is 1. So this is our unit circle, okay? Now what we're going to do in this lecture is we're going to talk about the angles within this unit circle. So this is an angle theta, okay? And the way that we define angles in the unit circle is we call the positive x-axis, which I want you to note can also be called the cosine of theta, because all of our angles here, the cosine is also the x, right? And our y-axis, which could also be called the sine of theta. Okay. So we could draw any angle. The angle is theta. And the angle starts at the positive x-axis. So notice I don't even have to draw the circle here. The fact that it's ending on the circle is kind of irrelevant to us in the moment. This positive x-axis is called the initial side. So every angle has two sides. The initial side of every angle that we have is going to be the positive x-axis. And then the side that marks off where the angle ends is called the terminal side. Okay. Now every angle has a coterminal angle. The coterminal angle is the rest of the circle. I'm going to use a different color because the blue is really hard to see. I want to use one that's easy to see the difference. So this angle here is 360 minus theta. This is the coterminal angle. Okay, so we have theta, and then what's coterminal? It shares a terminal side, okay? And notice that it goes all the way to the positive x-axis, okay? We said that this point on the unit circle is the cosine of your angle, the sine of your angle. So again, keep in mind that whatever the x value is of that point, that is also the cosine of the angle. Whatever the y value is, that is also the sine of the angle. So for example, at 30 degrees, I happen to know this, okay? Well, you'll get to it. At 30 degrees, the sine of 30 is 1/2. So that means that the y value at 30 degrees, so when we go 30 degrees around the unit circle, let's go back to that unit circle for a second. When we go 30 degrees, which is about here, I'm going to put that in for this moment. This is about 30 degrees, this distance, okay? We'll make this a little bit sharper. That's a 30-degree angle. And what we're saying is this 30-degree angle, I happen to know, and I'm going to tell you at the end of this lecture, the sine of 30 is 1/2. So the y value over here is 1/2, okay? If this is 1, this is 1/2. And the cosine is the square root of 3 over 2, which is about 0.8 something. So, so this is about 0.8, okay, the x value. But it's the sine of 30 and the cosine of 30, okay? Okay, so let's go back to this. So what we're going to look at today is something called reference angles. So a reference angle is the acute angle formed with the x-axis. And when we talk about reference angles, we're saying it could be the positive side of the x-axis or it could be the negative side. So we essentially have 4 possibilities, okay? And the 4 possibilities that we have, I'm going to draw them each separately. The 4 possibilities for our reference angle is we could have an angle in quadrant 1, and that angle, the acute angle, so we form 2 angles with the x-axis, right? I'm going to put, well, let's do the reference angle. This is one angle that we form with the x-axis. And here we're not talking about the coterminal angle, we're talking about the other side of it. Let's put it in this blue. This is the other angle that we form with the x-axis, right? But we want the acute angle. So the acute angle is our reference angle. So we could have our angle in quadrant 1. We could also have an angle in quadrant 2. And in this one, again, we have 2 angles that are formed with the x-axis. One of them is this one. That's one angle, but that's not the acute angle. Remember, an acute angle is less than 90 degrees. So the other angle that we have here is this one. This is our reference angle. Then we could have an angle in the third quadrant. And again, so I'm going to put a theta here, just so that you see where our reference angle is, okay? So we have this. This is our reference angle. So we have 2 angles that are formed with the x-axis. One of them is down here, and the other one is over here. This is our reference angle. And then finally, we could have a reference angle in quadrant 4, where this is our theta. I want to do that in a different color. Here's our x-axis. And here's our reference angle in quadrant 4. Okay, once again, we have 2 angles that are formed by the x-axis, but we want only the one that's acute, only the one that's less than 90 degrees, okay? So here's the thing, we have a reference angle in every quadrant, but that's not the way that we measure angles, right? We don't measure angles from the negative x-axis. We always measure our angles from the positive x-axis. So for a lot of these, what we want to do is we want to find the reference angle, okay? So we're given an angle, and we want to find what the reference angle is. And that's going to help us in a lot of different ways. Part of it is that if you remember, when we talk about the sine and the cosine and the tangent, we're only talking about right triangles, and right triangles don't have angles that are greater than 90 degrees. So what the reference angle does is it says, okay, we don't know how to find the sine and the cosine and the tangent of angles that are more than 90 degrees. So let's find the sine, the cosine, and the tangent of angles that are less than 90 degrees, of the reference angle. And the sines and the cosines and the tangents of the reference angle are the same as the sines, the cosines, and the tangents of the angle when we draw it from the positive x-axis. Okay, so what does this mean? Okay. Let's take a lot of examples. We're going to do a lot of examples where we're finding the reference angles, okay? And just in the interest of time and writing, I am not going to constantly put x and y. So please just know that this is the x-axis, this is the y-axis. That's always going to be true here, okay? But we're going to be doing a lot of these examples. Okay, so let's say, for example, I have this angle here. Now we want to find the reference angle. So we're in quadrant 1 here. The reference angle is the acute angle formed with the x-axis. So if we look here, the acute angle formed with the x-axis is the angle. So our reference angle here is just theta. Okay, so for example, let's take an angle in quadrant 1. This is, remember, it has to be less than 90 degrees. So let's say I'm giving this to you, that this is 72 degrees. Well, the reference angle then is just 72 degrees. Okay, it's just the angle itself. So if we take another example, another angle that we put here, and we say that this is 21 degrees, we're saying our reference angle is also 21 degrees. Okay, because again, how do we define the angle? We look at its measure from the positive x-axis to its terminal side. This is telling us that the distance between the positive x-axis and the terminal side is 72 degrees. Well, that's less than 90 already, so that's our reference angle. Same thing is true here for 21 degrees. That's already less than 90, so that's our reference angle. Okay? And it kind of makes sense because right triangles, all of the angles are already less than 90. And here, in quadrant 1, all of our angles are less than 90. Let's take a look at quadrant 2. So if we take an angle in quadrant 2, we measure our angle. This would be our theta, okay? I don't want to confuse you here. Over here, I put this as our theta, okay? But we're really measuring, when I'm giving you an angle, I'm giving you this angle here. I'm giving you the blue side, okay? So that's what we mean. Remember, theta just is a variable, so we can use it to define anything, as long as it's an angle. So here, I give you theta, but your reference angle is not theta here. Your reference angle is this angle right here. And that's what you want to find, okay? You want to find, okay, this is theta. What is this angle that's over here? So let's do a few examples and see if you can figure out how we would find it just in general. So let's say that you're given the angle here, and this is 110 degrees. Okay, now I want to remind you that it's got to be bigger than 90, but it's got to be less than 180, right? Because we said if we go as far as the y-axis, then you're at 90 degrees. And if you go as far as the other side of the x-axis, you're at 180 degrees. You're halfway around the circle. So this distance here would be 110 degrees, okay? this is your reference angle. This is the angle that you want to find right here. So the question is, how do you find that angle? Okay, well, we know that halfway around the circle is 180. What we can do is we could take this 110 degrees away. Because if we take away the 110 degrees, then we're left with the reference angle. So imagine this, okay? This is what's going on here. We want this distance here. So what do? We take the whole distance and we take off the part that we know. We take out the 110 degrees. We're taking that out. So now we have 180 degrees minus the 110 degrees. And what are we left with? 70 degrees. So our reference angle here is 70. We're subtracting our theta from 180. And that's giving us the 70. Let's take another one. Again, we'll do quadrant 2. So let's say that I give you an angle of 162 degrees. I put an arrow on the end here. It really doesn't make a difference if you have an arrow or not. Because right now we're just looking at reference angles. So if this is 162 degrees, our reference angle is made with the x-axis. So I want you to note that you're never, ever, ever subtracting or adding or anything to 90 degrees or 270 degrees. That's on the y-axis. The reference angle has nothing to do with the y-axis. The only thing that the y-axis tells you is what quadrant you're in, okay? And I'm going to actually put that off to the side as something really important, because it is. This is the most common mistake. It has nothing to do with the y-axis. So we never use 90 degrees or pi over 2, right? Right now we've been looking at everything in degrees, but you can do this in radians too. Or the 270 degrees, which is 3 pi over 2, to find the reference angles. Okay, the only purpose of the y-axis is to tell you what quadrant the angle is in. Okay, that is the only thing, the only purpose. So I'm going to box this. This is really important. It is the most common mistake that I see people make. They look at the angles and they say, oh, it's the acute angle with the y-axis. It's not. It's the acute angle with the x-axis. So here in this one with the 162 degrees, we have our two angles. We have 162. And then we have this one here. This is our reference angle. And in order to find this, we can see that once again, we can do 180 degrees, and then we subtract the 162 that's there. And we get 18 degrees. Okay, so that means that we can actually generalize, right? Because we can kind of see that that's always going to happen. We're always going to be doing the 180 degrees minus the angle that we're given. And the angle that we're given is theta. So our reference angle is always going to be 180 minus theta in quadrant 2. Okay, and we'll summarize this at the end. Okay, so now we have quadrant 1 and quadrant 2. Quadrant 1, it's the angle itself because the angle is already less than 90. Quadrant 2, we could see that we do 180 minus theta. Then we have quadrant 3. So let's look at some angles in quadrant 3. So in quadrant 3, your angle, again, it is defined. Every angle that we have is defined starting at the positive x-axis and going around to the terminal side. This is your theta, okay? And angles in the quadrant 3 are going to be between 180 degrees and 270 degrees. And what's our reference angle here? Our reference angle is the acute angle formed with the x-axis. So we have two angles formed with the x-axis. We have this small one here. And we have the remainder of the circle, okay? But we don't care about that. The one that we want is this one here. This is our reference angle. Okay. So let's do some examples and then we'll see if we can generalize. You can already, some of you may already figure out how to generalize this. So again, you're only going to see angles that are between 180 degrees and 270 degrees. Those are the only angles that would be in quadrant 3. So if I give you an angle like this and I tell you this is 245 degrees. Okay, well, what is our reference angle? Our reference angle is this. Okay, so let's think about what's going on here. We have something that looks like this. I'm going to draw a line here just so that you could see what's going on. We go halfway around the circle and then we add some. Now we want what's between these two lines. So if we only want what's between these two lines, that means we have to get rid of this half circle. We're getting rid of this. We're taking it out. Well, what is that measurement? That measurement is 180 degrees. So we're saying we're doing the whole thing, and then we're going to get rid of 180 degrees, and that's going to leave us with our reference angle. So we're going to take our whole 245, and we're going to subtract 180 degrees. And that's going to give us our reference angle. And if we do 245 minus 180, we get 65 degrees. And let me be clear about what this is telling us. This is telling us that the sine of 245 degrees is the same as the sine of 65. The cosine of 245 degrees is the same as the cosine of 65. And the tangent of 240 degrees is the same as the tangent of 65. The only thing that changes, which we'll talk about in a little while, is whether or not the sines are equivalent, but one is positive and one is negative. We'll talk about that later, okay? But the sines and the cosines of the angles are the same. So what that means is We only need to know the sines, the cosines, and the tangents of the angles in the first quadrant. If we know the sines and the cosines of the angles in the first quadrant, we know all of those angles. We know the same thing for all of the angles in the second, third, and fourth quadrants. Okay, so that's just why we're doing this and why we care about reference angles. Let's take another one. Let's say that we're told that this angle is 190 degrees. Okay, so once again, you're taking the 190 degrees and you're subtracting that half circle because you don't need that half circle. Your reference angle is only this small piece here. So we're taking out the half circle. 190 minus 180 is just 10 degrees. This is your reference angle. Which means that we can generalize. We are doing the same thing each time. What we're doing is we're saying, okay, we'll take your angle theta, but then subtract 180 from it, and that will give you your reference angle. Okay, let's take angles in quadrant 4. So here's an angle where this is what we would name theta. So notice again, we start at the positive x-axis and we go all the way around to the terminal side. We always go clockwise, okay? If we go we always go counterclockwise. If we go clockwise, that's change in direction. And if you remember, a change in direction says put a negative sign in front of the angle. Okay, but what we're doing is we're starting from here. We're always looking at positive thetas. Now our reference angle is this small piece right here, which we don't see in the original angle. Okay, so let's take some examples and see if we could generalize the same way that we generalized in the others. So remember, angles in quadrant 4 are between 270 degrees and 360 degrees, okay? So let's say, for example, that we have an angle that is 295 degrees. Okay, well, let's talk for a second about what this means. We're going to do the same thing that we did before, okay, where like what we did here, where we said, okay, well, we're erasing this part. We're erasing this part. We're going to do the same thing over here. So over here, we have our angle. But what we could do is we could draw a whole circle. And our angle is somewhere over here. Well, if we take the whole circle, right, the whole 360 degrees, and we subtract what we don't need from that 360 degrees, which is the angle. If we take this out, this is our theta. Then look at what we're left with. We're left with our reference angle. So if we take a whole circle and subtract the angle that we're given, then we're left with our reference angle. What does this mean for the 295? This means if we take 360 degrees, which includes the reference angle, notice when we add in what the reference angle is, we get a whole circle. Well, if we take the whole circle and we subtract 295, that gives us the reference angle. So we took 360 degrees, took out the 295 that we didn't want. That's this purple part that we're erasing. And that gives us the reference angle that we need. Let's do another example. Let's say that you're given an angle of 276 degrees. Okay. Well, once again, we can describe our reference angle. Here's our reference angle. And once again, we create a full circle when we put in that reference angle. So we could take the full circle and subtract the 276 degrees. And that's going to give us 84 degrees. So our reference angle is 84. And notice these are all numbers that are less than 90. You should not be getting numbers that are greater than 90. Okay? You should not be getting numbers that are greater than 90. If you are, then you're not getting a reference angle. A reference angle is an acute angle with the x-axis. Okay? Notice that our reference angle is here. It is not with the y-axis. This is not a reference angle. Okay? Our reference angle is only with the x-axis. So let's generalize. Okay? So where it's saying that we take, with the reference angle, we have 360 degrees. We only want this piece. So what we can do is we could subtract the piece that we're given, and we'll be left with that piece that was originally empty. That's now our reference angle. So we can generalize. The reference angle is saying take 360 degrees and subtract your theta. Okay, let's summarize. Okay. So here are the different cases. So remember, we have quadrant 1. We have quadrant 2, which I'm just going to abbreviate with a Q. Quadrant 3, notice we always use Roman numerals. That doesn't change. And quadrant 4. So you shouldn't just be writing a 1 and then just a regular 2. You should be using Roman numerals. Okay, let's talk about how to find our reference angles. So in quadrant 1, we said, if we go back to what we did in quadrant 1, we said that the angle in quadrant 1 is just the angle itself because it is already a reference angle. It is already acute. So our reference angle in quadrant 1 is just theta. Okay. In quadrant 2, we said, okay, quadrant 2, here's our reference angle. It's this piece over here, this small piece. So what do? We take 180 degrees and we subtract the theta that we're given, and that's going to leave us with our reference angle. So in quadrant 2, we can find our reference angle by doing 180 minus theta. Quadrant 3, if we look at what we did here, we had our angle, and what we did is we said, okay, well, we're going past the x-axis, okay? We're going past 180 degrees plus some. Now that plus sum is our reference angle. So what do we want to do? We want to take our angle, but we're going to subtract 180 degrees from it. We're going to take out that half circle that we don't want. So in quadrant 3, we take our angle and we subtract 180 degrees. And finally, in quadrant 4, we said, well, we could go all the way around the circle and then subtract the angle, and what we're going to be left with is our reference angle. So it would be 360 degrees minus theta. Okay, how does this change if our angle is in radians? Well, it doesn't really change. If we're in radians, in the first quadrant, our angle is still the reference angle, so it's still theta. In the second quadrant, well, instead of doing 180 degrees minus theta, 180 degrees is pi radians. So we're just going to do pi minus theta. And over here, again, 180 degrees is just pi radians. So if our angle is in radians, we would just subtract pi. And 360 degrees is 2 pi. So we would just do 2 pi minus theta. So these bottom ones are if the angle is in radians. And the top one is if the angle is in degrees. Okay, so this is how we find our reference angles. Let's just do a couple of examples where I don't tell you ahead of time what quadrant we're in. Let's say that we wanted to find the reference angle. I'm just going to do like 3 examples, so you should do these again. I'll write them all out now so that you can try it on your own, and you can pause the tape. Such an old word, sorry. You can pause the video, and then you can start playing it again so that you can see whether you got the answers right. So let's find the reference angle. For, let's say I give you 92 degrees, 118 degrees, and 296 degrees. Okay. You should pause, try and do it, and then press play again. So for 92 degrees, you have to figure out what quadrant you're in. Well, 92 degrees is more than 90 but less than 180. We're in quadrant 2. Again, if you look at your unit circle, remember that this point right here is 0 degrees. We travel here. When we get here, it's 92 degrees. It is 90 degrees. When we get to 92, we haven't reached the 180 degrees yet. So we're in quadrant 2. This is 92. Now we want to find the reference angle. The reference angle is going to be this angle right here. And we know that what we can do is we could take 180 and subtract 92. And we get 88 degrees here. So that would be our reference angle. Okay, let's do the same thing for 118 degrees. So 118 degrees. So once again, we want to figure out what quadrant we're in. So 118 degrees, we're past the 90 degrees, but we actually don't go past 180. We're in quadrant 2 again. This is 118 degrees. We're just a little further into quadrant 2. So our reference angle, once again, is the angle made with the x-axis, the x-axis. So this here is your reference angle. So we can do, once again, 180 minus 118 degrees. So for each of these, you have to figure out what quadrant are you in, and that's going to tell you how to. So once again, we're in quadrant 2. That's going to tell you how to figure out your answer. Okay, 296 degrees. Well, if we look here, if we go this far, we're only at 90. If we go this far, we're only at 90. If we keep going, we're at 180 now. If we keep going to here, we're only at 270. So we're actually 296 degrees is going to be in quadrant 4. This is 296. Our reference angle is over here. So we would do 360 minus 296. They should all have degrees because we're not working in radians. 360 minus 296, which gives us 64 degrees. Okay, so those are our reference angles. Now, if I gave you an angle in radians, then instead of doing 180 minus the angle, you would just do pi minus the angle. Okay, I'm not giving you the angles in radians at the moment because you're not as familiar with where things are, with where the angles are in the x on the coordinate plane, like what quadrant it's in. So I'm going to wait to do that. Okay, here's what this means. This means that the sine of 92 degrees is the same as the sine of is the same as the sine of 88 degrees, okay? This is why we do this, because the sines of an angle are the same as the sines of the reference angle, okay? So let's talk about sine, cosine, and tangent for a minute. Let's like really talk about it in terms of the axis, okay? So we're gonna go back to our unit circle. I'm not even gonna draw the exact circle. We're just gonna draw the axes again. And we know something here. We know that the x-axis, whatever your x values are, those are also the cosines. And whatever your y values are, those are also the sines of your angle. This y didn't come out. So for right now, let's just talk about the sines of these trig functions, okay? So when we talk about the sine of the trig function, we mean SIGN, whether it's positive or negative, okay? So we're looking at where it is on the coordinate plane. That's going to tell us whether something is positive or negative. So for example, in quadrant 1, you're looking at your x values and your y values. Well, your x values here are positive, so your cosines are all going to be positive. So in other words, we know that the cosine of 25 is positive. The cosine of 86 is positive. The cosine of 11 is positive. For any angle between 0 and 90 degrees, the cosine is going to be positive because the x values are positive, okay? If we look in quadrant 2, well, now the x values are negative. So the cosines are going to be negative. The cosine of 92 degrees is going to be a negative number because the x value at 92 degrees, remember the x, if this is x comma y up here, the x is negative, okay, at that point, at that coordinate. So the cosine of theta in quadrant 2 is negative. Now the same thing is true in quadrant 3, right? Any point in quadrant 3, our x value is going to be negative. And since our x values are the same as the cosines, what that tells us is that the cosines are negative here. And finally in quadrant 4, well, in quadrant 4, our x values are positive. So once again, our cosine is positive. Okay, let's look at the sines. So the sines, we're not looking at the x values, we're looking at the y values. So in quadrant 1, you're thinking of your coordinates and you're saying, are your y coordinates positive in quadrant 1 or negative? And the y coordinates here are all going to be positive. If I were to plot a point right there, okay, and I were just to make up a coordinate, I would have a positive y value. I would never make the y value negative there. So our sines are also positive here. Over here, once again, our y values are positive, so our sines are positive. And then down here in quadrant 3, our sines are now negative. Any y coordinate that we have here is a negative y coordinate. And the same thing would be true in quadrant 4. Once again, our y values are all negative here. So the sine of any angle that's in quadrant 4 is going to be negative. So in other words, the sine of 296 degrees is negative. Now the sine of 64 is positive. So the sine of 296 and the sine of 64 are the same thing, except this is a positive number and this is a negative number. Okay? So that's why we have reference angles, and that's why we want to know this, because we're saying, okay, the sines are the same, okay? The sines or the cosines, they're all the same, but one is going to be positive, one is going to be negative, or sometimes maybe they're both positive, okay? Or they're both negative, okay? So for example, the sine of 62 is going to be the same as the sine of 118, okay? But, and they're both going to be positive because one is in quadrant 1, one is in quadrant 2, and in quadrant 2, the sines are the, quadrant 1 and quadrant 2, the sines are the same. Okay, so the sines and the cosines of the reference angle and the angle are the same, but sometimes one is positive and one is negative. This is what you think about in order to figure out which is which. Okay, now we can also figure out the tangents, because it turns out that the tangent of an angle is equal to the sine of the angle over the cosine of the angle. So we'll come back to this in a second. I want to prove it first. So on the next page, I'm just going to prove it. The tangent is equal to the sine over the cosine. That's what we're trying to prove. Okay. Well, the sine over the cosine, sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse, right? Well, what we're going to do is we don't like fractions within fractions, so we're going to get rid of that. And we're going to get rid of it the way that we usually do. We're going to multiply by the reciprocal of the denominator, right? Because then the h's cancel and the a's cancel. But what we do on bottom, we have to do on top. We're going to multiply by the reciprocal of the denominator on top. Okay, and if we multiply by the reciprocal of the denominator on top, let's see what happens. We get O over H times H over A. But the H's cancel. So we get O over A, which is equal to the tangent of theta. So that's our proof. Okay, let's go back. Now that we know that tangent is sine over cosine, we can figure out the sines, S-I-G-N, of tangent. Because tangent is a positive over a positive. That's positive. A positive over a negative is negative. A negative over a negative is positive. And finally, a negative over a positive is negative. And I want you to understand this. I don't want you to memorize it. I want you to understand how we're getting whether or not sine, cosine, and tangent are positive in each of the axes. But there is a mnemonic to remember, so I will show it to you, even though I hesitate. And the mnemonic is all students take calculus. And there are variations on this mnemonic. But the first letter tells you what is positive. So in the all, the A tells you all of them are positive. Here we have students. The S tells you that the sine is positive. Then we have take. The T tells you only the tangent is positive. And then you have calculus. So the C tells you only the cosine is positive. Okay, so this is just a mnemonic to help you, just if you just want to check that you're correct. Okay, I want you to understand what's going on here though. Okay, so what does this mean? This means that the sine of 92 degrees is the same thing as the sine of 88 degrees, okay? The sine of an angle is equal to the sine of its reference angle, okay? That's because the circle is symmetrical. So I'm going to put this on the other page too, but we're going to come back here. So the unit circle is symmetrical. Every reference angle has 4 angles that are equivalent, okay? So if this angle here is 88 degrees, it has 3 other angles, okay, with a reference angle of 88 degrees, where the sine, the cosine, and the tangent are the same. It's just that some are positive, some are negative. So this is 92 degrees. 92 degrees has a reference angle of 88. Its reference angle is 88 degrees. Okay, the sine is the same. The y values are the same here. The sine of 92 is equal to the sine of the 88. That is not true for the cosine though, right? cosine, if we look at the x values, circle is symmetrical, okay? Which means these two lines, right? If you look at the y-axis is a line of symmetry when you put them together. The cosines are the same, but the cosine of 88 is positive and the cosine of 92 is negative because 92 is in the second quadrant. So the cosine of 92 is negative the cosine of 88. Okay, so 92 degrees has a reference angle of 88. That's why we're saying that they're the same. Now 92 degrees is the angle in the second quadrant that has a reference angle of 88. But we have an angle in the third quadrant that has a reference angle of 88 as well. Okay, that angle is 268 degrees. Okay, how did I find that? I just did 180. I know that my reference angle is 88. So I just did 180 plus 88. Okay, and here's what I know about that. I know that the sine of 268 is the same as the sine of 88, but the sine of 88 is positive, the sine of 268 is negative. So the sine of 88, the sine of 268, let's do tangent first of 92. The tangent of 92 degrees, well, in quadrant 1, the tangent is positive, but in quadrant 2, the tangent is negative. So it's negative tangent of 88. If we go to 268, the sine of 268 is the same as the sine of 88. It's the same as the sine of its reference angle, but its reference angle, 88 degrees, has a positive sign. This has a negative sign. The cosine, I wrote 268. I meant 88. The cosine of 268, it's the same problem. Okay, 88 has a positive cosine. It has a positive x value. This has a negative x value. Okay, so the cosine of 268 is negative the cosine of 88. And then tangent, well, tangent is positive in quadrant 1 and it's positive in quadrant 3. So the tangent of 268 is the same as the tangent of 88. So 268 degrees also has a reference angle of 88 degrees. Okay, which is why we can equate their sines, their cosines, and their tangents. Now we have one more angle. We have an angle in quadrant 4. Okay, and the angle in quadrant 4 that has a reference angle of 88 degrees is 272 degrees. So once again, we have a reference angle of 88. So we can equate the sines, the cosines, and the tangents there. The sine of 272 well, the sine is the same as the sine of 88, but the sine of 88 is positive. Sine of 272 is negative. For the cosine of 272 is positive. So it's the same as the cosine of 88. And the tangent of 272, we know in quadrant 4, tangent is negative. So this is negative, the tangent of 88. Okay, we're comparing them because 272 has a reference angle of 88 degrees. So if we go back here to these, we had 118 degrees. Well, 118 degrees has a reference angle of 62. The sine of 62 is going to be the same as the sine of 118 because they both have positive y values. The cosine of 118, though, is going to be negative the cosine of 62. The cosine of 118 degrees is negative the cosine of 62. Because in quadrant 1, cosine is positive, but in quadrant 2, cosine is negative. So the sines are the same, but the cosines are not. And the tangents aren't the same either. Because in quadrant 1, tangent is positive, but in quadrant 2, tangent is negative. And then if we do the same thing here, we're saying that the sines and the cosines of 296 and 64 are the same, but the sine of 296 is negative the sine of 64 because the sine of 64 is positive, but the 296 in quadrant 4, the sines are negative. Okay. The cosines are the same. Cosine in quadrant 1 and quadrant 4 are both positive. So the cosine of 296 is equal to the cosine of 64. And the tangents are not the same because the tangent in quadrant 1 is positive, but in quadrant 4, it's negative. So this would be negative tangent 64. Okay. That's why we care about reference angles, because then we only need to know the sines, the cosines, and the tangents of 0 through 90, or 0 through pi over 2 if we're working in radians. And we don't have to know the sines, the cosines, and the tangents of any of the other angles. We just have to know, hey, 296 is in quadrant 4, so I know that the reference angle is 64. I could take the sine, the cosine, and the tangent of 64. I just have to figure out, is it a positive sign or a negative sign? Okay. Okay. So we have certain angles, okay, that we look at typically. And this is an exact value chart. This is something you need to know, okay? And all of your exams are take-home exams. You have all of this stuff in front of you. But when you go into your calculus class next semester, if they ask you what the sine of 30 degrees is and you do not know, that's going to be a problem. So you need to know these exact values, okay? So let's determine these exact values. I'm going to show you how to remember them. There are 2 ways to remember them. And we're going to work with these a lot more, with this too, when we do trigonometric equations. So I'm introducing the idea, okay? We're going to do a lot more with this when we do the trigonometric equations, and we won't just work with degrees, we'll also work with radians, okay? So we have, you can either use 2 triangles, okay? You can use a 45, 45, 90 triangle, okay? And a 30, 60 degree 90 triangle. These are special angles that you should know the sine, the cosine, and the tangent of, okay? And if you remember 2 sides of the triangle, then you know the 3rd side. So the way that a 30, 60 degree triangle looks is that the opposite side of the 30 is 1, the hypotenuse is double that. If you can remember that, then you could figure out that this is the square root of 3. Here, each of these are the square root of 2, and this is 2. So what does this tell you? It tells you, hey, the sine of 45 is square root of 2 over 2 because opposite over hypotenuse. okay? The cosine of 45 is also equal to square root of 2 over 2. And the tangent of 45 is the square root of 2 over the square root of 2, or 1. So this will help you remember sine, cosine, and tangent of 45 degrees. Now you also have to know the sine, cosine, and tangent of 30 degrees. So the sine of 30 degrees, if we do opposite over hypotenuse, is 1/2. The cosine of 30 degrees is adjacent over hypotenuse, which is square root of 3 over 2. And the tangent of 30 degrees is opposite over adjacent, so it's 1 over the square root of 3, which is equal to the square root of 3 over 3 when we rationalize the denominator. And you can't see that at all. Sorry about that. It's equal to the 1 over the square root of 3 when we rationalize the denominator. That's the square root of 3 over 3. You still can't see it. What's going on? My pen stopped working. Hold on, I'm going to pause the tape and get the pen to work. Okay, so it should be working now. It is, you just still can't see it. So, once again, the tangent of 30 degrees is 1 over square root of 3. And then we rationalize, and it becomes square root of 3 over 3. And then we could do the same thing for the sine, the cosine, and the tangent of 60 degrees. So the sine of 60 is the opposite, right? It's square root of 3 over 2. So notice that's the cosine of 30, okay? It makes sense because the sine of 30, the opposite is 1, but for 60, the opposite is square root of 3. And for 30, the adjacent is square root of 3, but for 60, the adjacent is 1. So the opposite and the adjacent switch because you're switching the angle that you're looking at. So the sine of 60 is square root of 3 over 2. The cosine of 60 is 1/2. And the tangent of 60 is just square root of 3 over 1, which is square root of 3. Okay, so if you want to do it that way, you can. You just need to remember these two triangles. Now you also have to know the sine and the cosine and the tangent of 0 and 90, but that you can get from the unit circle, right? The sine of 90 is, the sine of 0 is 0, the cosine of 0 is 1, and we know that tangent is sine over cosine. So it's 0 over 1. The tangent of 0 is 0. For 90, the sine of 90 is 1. The cosine of 90 is 0. The tangent is 1 over 0, so it would be undefined. Okay, so you can get the sine, the cosine, and the tangent of 0 and 90 from the unit circle. Okay, there's another way, and this is the last thing I'm going to show you. You can use an exact value chart, okay? And it's kind of cool the way that you can form the chart. So we need to know the sine, we need to know the cosine, and we need to know the tangent. The angles that we need to know are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now I want to emphasize that you don't just need to know it in degrees. You have to know it in radians too. Remember, we use radians more often than degrees. So in radians, this is 0 radians. This is pi over 6, right? 180 over 6 is 30 degrees. This is pi over 4. 180 over 4 is 45 degrees. Pi over 3 and pi over 2. So these are the angles in radians. You have to know both. We haven't been emphasizing this, but you have to know both. So here's how you do it. I'm going to do it in blue. Let me first draw boxes because I want to make sure that you are clear about what belongs to what. So all of these are ratios, right? Sines, cosines, tangents, they're all ratios. So for all of these, we're going to have fractions. All of these have fractions. So every one of these has a fraction, okay? The denominators for sine and cosine are all 2. Okay. The numerators for sine, it's 0, 1, 2, 3, 4. 0, 1, 2, 3, 4, and we just take the square roots. For cosine, it's 4, 3, 2, 1, 0. And we take the square roots. For tangent, it's sine over cosine, so the denominators will cancel, okay? Think of it this way, if I were to write this as where this line represented a division sign, okay, you would multiply this by 2 over square root of 4. You would multiply this by 2 over square root of 4. The 2's would cancel. This is a 3, by the way. Which means that the numerators here are the numerators of sine. And the denominators are the numerators of cosine. So 0, 1, 2, 3, 4 over 4, 3, 2, 1, 0. Okay, and of course you want to simplify, so I'll put that in red so that you could, in pink, so that you could easily see the simplification. Square root of 0 is 0, so 0 over 2 is 0. Square root of 1 is 1, so this is 1/2. Square root of 2 over 2, you can't simplify. Square root of 3 over 2, you can't simplify. Square root of 4 is 2. 2 over 2 is 1. Then this simplifies the same way. 2 over 2 is 1. Next 2 can't be simplified. This is 1/2. And this is 0. Square root of 0 over square root of 4 is 0. This is, square root of 1 is 1. This is your 1 over square root of 3. You rationalize your denominator. Square root of 2 over square root of 2 is 1. This we could just say is square root of 3. And this is undefined. So you would do the same thing that you usually do. You would simplify your fractions, reduce them, and then you would rationalize your denominators. And the only one that you have to worry about here is this one. And here's what this is telling you, okay? This is telling you that the tangent of 30 degrees is square root of 3 over 3, okay? So tangent, 30 degrees, square root of 3 over 3. It's telling you that the cosine of pi over 4, so you're going to row cosine, column pi over 4, is square root of 2 over 2. Now this also tells you the tangent of any angle that has a reference angle of 30 degrees, right? So for example, 150 degrees has a reference angle of 30 degrees. So you also know the tangent of 150, okay? Tangent of 30 is positive, tangent of 150, it turns out, is negative. So the tangent of 150 degrees would just be negative root 3 over 3. The cosine of 60 degrees, cosine 60 is 1/2. The sine of 0, sine 0 is 0. The cosine of pi over 2, well, we have cosine pi over 2 is 0. The tangent of pi over 3, tangent pi over 3 is square root of 3. That's what this is telling you. And like I said, why is this helpful? Because it tells you the sines, the cosines, and the tangents of every angle that's equal, that has the same reference angle, okay? And one last thing I want to show you. You don't have to know this whole chart, okay? You know that tangent is sine over cosine. So if you know the sines and the cosines, you know what tangent is, okay? Because you just take sine over cosine. You can also see that because the opposite and the adjacent switch depending on the perspective, like we talked about with the 30 and the 60, okay? The sine of an angle is equal to the cosine of its complement. The sine of 0 is the same thing as the cosine of 90. The sine of 30 is the same thing as the cosine of 60. The sine of 45 is the same thing as the cosine of 45. Sine of 60 is the same thing as the cosine of 30. Sine of 90 is the same thing as the cosine of 0. The sine of an angle is equal to the cosine of its complement. So sine of 20 degrees is equal to the cosine of 70 degrees. The sine of 80 degrees is equal to the cosine of 10 degrees. The sine of 45 degrees equals the cosine of 45 degrees. The sine of 30 degrees is equal to the cosine of 60 degrees. Okay, so you can use that to help you so that you don't have to know the whole chart. Okay, you do have to know this chart. If this were an in-class test, I would not give you this chart. Okay, you would have to know it. So you're going to have this chart in front of you. There's nothing I could do about that. You're going to have this chart in front of you when you take the test. If it's asking for an exact value, this is what they're talking about, the square root of 3 over 3. Do not find what the square root of 3 is, okay? Do not get a decimal. You leave it like this if it's asking you for exact values. And for calculus, you need to know this. You need to memorize it. So create flashcards, and over the summer, you should all be memorizing this. Okay? Okay, that's it for today. I know it was a lot.